Hello, everyone, and welcome to today's webinar on Voices Public Engagement. My name is Kevin Vita, and I'll be helping facilitate today's webinar. This webinar is sponsored by the Federal Highway Administration and hosted by the National Operations Center of Excellence. NOCO offers a variety of resources to support the transportation systems management and operations community. On the bottom right side of your screen, you can see a box called Useful Links. You can browse through those links for TSMO-related news and resources. Previous webinar recordings related to this topic can also be accessed from there. Now for a few logistical items. We are recording today's webinar, and the recording, along with the presentation slides, will be available through the on-demand learning section of our website. All the attendees are in listen-only mode by default, but we'd like you to stay engaged by using the Q&A and discussion pod for comments and questions. We'll have a Q&A session at the end of the webinar. We encourage you to enter any questions you have in the Q&A pod as they come to your mind during the presentations today. The questions will be read aloud one at a time by the moderator, and our presenters will answer each question. So that's all I have, and with that, I'll hand it over to our moderator, Nicole Pallado, to start us off.
Thanks, Kevin. Good afternoon, everyone. My name is Nicole Pallado. I'm a communications specialist with Leidos, and I will be your moderator for today. Thank you all for attending. First, I will introduce our speakers, Rob and Taylor. Rob is the director of the U.S. Department of Transportation's Highly Automated Systems Safety Center of Excellence within the Office of the Assistant Secretary for Research and Technology. And Taylor is the CARMA Program Manager for the Cooperative Automation Research Program in the Office of Operations Research and Development, located at Turner Fairbanks Highway Research Center. Our agenda for today is an introduction to Voices, as well as a technical overview and schedule of upcoming events. There will be a question and answer portion, like Kevin mentioned, at the end of the presentation, but feel free to add any questions or comments as we go along through the presentations, and we will do our best to address all of those at the end. So the objectives of today's webinar are to define the background of Voices, provide a broad technical overview of the platform, discuss the schedule, and hear your feedback and questions. So with that, I will hand it over to Rob to get us started.
Thank you, Nicole. This is Rob Heilman. Very happy to be with you today. Thanks for joining us. I got to tell you, after 2 years of dealing with this rather interesting, somewhat bizarre situation of a pandemic and remote work, is still a little weird not being able to see any of you as we essentially perform these types of venues in a virtual world. This is a marvelous platform that we're using, rather intuitive, and appreciate all of the great support that we're getting. Though sure would be nice to be able to be in the same physical environment with you all and be able to look you eye to eye. But until then, we'll do our best to do this in a virtual environment. I'm going to provide you with an introduction to Voices, along with the role that Nicole mentioned. I have the distinct pleasure of being the technical lead and just recently the program lead for Voices. My cohort here, my brother in arms for this presentation, is also my brother in arms for Voices in terms of the technical lead for the DOT side of Voices on the federal highway side, Taylor. So we'll be tag teaming this presentation. I'll provide the general overview, and then on the technical meat of the presentation, as Nicole mentioned, turning that over to Taylor. So with that, we're going to start off by providing a bit of almost like a vision of where we see the transportation system heading into the future. I'd be curious, this is where it'd be nice if we could actually see each other. I'd be curious if you guys think that we're in the midst of a bit of a change in transportation. Do you believe that we're undergoing a bit of a time of transformation? Do you believe that we're entering into a new era. Are we really at that point? Personally, I believe that we're actually at an inflection point, that the bright line that once separated the different modes of transportation, from space to aviation to surface, and then even further segmenting surface into heavy vehicle, light vehicle, rail, maritime. I believe that, and those of us in Voices believe that those bright lines are dissolving. They're dissolving rather quickly. We're moving towards a holistic, integrated, ubiquitously connected, and more intelligent system of systems. The transportation system of the future is, in our view, in fact, becoming a system. And so we believe that we need to start managing, engineering, architecting, testing this system as a system of systems. What's going to be stitching these different modes of the system together are networks. The data that flows through those networks will be the lifeblood of the system. And all of the different platforms that traverse those systems, and they're going to be traversing these different modes, are going to be sharing data with each other through these networks. These systems are going to be interacting with each other, and you're going to have what have been traditionally aviation systems interacting with what have been traditionally surface infrastructure, and in some cases, traditionally surface platforms. If you take a look at things like UAS, unmanned aerial systems, that will be delivering, let's say, packages, be it your pizza or perhaps some type of a package that you ordered online, right? That's going to be taken off from the surface. It's going to be going to low altitude aviation, kind of back down towards the surface, and then dropping something definitely into the surface. All right? And so in that process, it's going to be sharing spectrum. It's going to be sharing the RF environment, and it's going to be rather in close proximity with the surface transportation ecosystem, right? That are working on. I was actually in a conversation today with some folks from the FAA on the UAS traffic management system, and that people are working on traffic management systems for surface transportation. How is it will the UTM, the UAS traffic management system, work with surface traffic management systems? How will they interact? How will those various networks play together? And then how will these various systems interoperate with each other? If everybody is working on their individual systems, be them mobile systems, be that fixed digital infrastructure, be those networks, be that cloud infrastructure, be it traditional aviation or surface systems, or if we have transcontinental suborbital space vehicles that take off at the surface, go to aviation, go to suborbital, space, and then let's do transcontinental passenger travel to try to get from, let's say, LA to Tokyo in a couple of hours, or New York to Europe in a couple of hours. Then how are these various systems going to interact and intercommunicate with each other? And how do we test those? And if we test them in isolation, and if we explore the different concepts of operations, right? And if the first time you get to test or interact or to somehow experiment with your concept of operations with the other systems, with the networks, with the data, with the infrastructure that you're going to have to interact with in the real world, if the first time you do that is when you're in the real world, I believe that we are heading towards, well, not a very bright future. We are certainly not going to get there very seamlessly. We are not going to be very interoperable, right? And I don't believe that we're going to be very secure from a cybersecurity perspective. Actually, I think we're going to be pretty damn hosed. And so, so what we're trying to do is to figure out how can we shift all of that exploration, that experimentation, that concept of operation type of engineering, the entire systems engineering process, the demonstration, verification, validation, certification, testing process, how can we shift that all to the left? How can that be performed in a collaborative system-to-system manner before you have to get out of the lab, right? And then before you get out into the real world in a cost-effective and safe way, right? That is the problem we are trying to solve. And there is no way any individual entity can do that alone. So that is what we are trying to do. Okay? The problem with doing that alone, right, is that there is no simple, effective, efficient, affordable mechanism right now to do collaborative research and testing. There are just too many of us that are in the game. There are too many of you that are in the game. And the ones that are leading the pack have really, really deep pockets. And then if you just take a look at the government, the public agencies, just look at how many of them there are. You know, you got all the states, you got, of course, a Fed, but then with the Fed, if you look across aviation, if you look across surface, right? And then you look at security, you got DHS, right? Then you look at, even in aviation, you got NASA, right, along with FAA. I mean, and then you got the regions along with the states, right? And then you got the cities. I mean, it's just such a fragmented collage of players, even in the public sector, let alone the private sector, right? So the multiplicity of stakeholders is just a mess. It's so fragmented. And that's just part of who America is, right? We are not a centrally controlled society. That's part of what makes us strong, and it's also part of what makes this pretty hard, right? So how do we start to solve that problem? How do we start to somehow dial in what makes us strong and deal what makes us just a bit difficult, okay? There's also these natural silos that comes with all of this fragmentation. And those silos, as we all know, are fortified. They are strong walls, right? And they are tough to get through. There's also, along with those silos, a lack of trust, right? We don't trust each other. And there's a lot of reasons why. And that lack of trust is built on history, right? There's reasons for a lack of trust. And there's a lot of money that's being spent. There's a lot of venture capital that has been put in place. There's a lot of intellectual property and secret sauce, right? And so we are capitalists. That is also part of what makes us who we are, right? Those of us in the government, Taylor and I are government folk, right? We respect that, right? We understand that. We don't own your data if you are a commercial player, right? So we need to figure out how to manage that situation. Privacy, right? The commercial people, you don't own the private citizens' data. That is just the way it is. And so we got to figure all of that out, right? So how do we deal with intellectual property protection, and how do we deal with data rights, data ownership, privacy, and PII, right? So we need a way of being able to collaboratively perform this kind of research and testing and systems engineering while protecting intellectual property and privacy, and also cost and resource barriers. It cannot cost a fortune to be able to do collaborative research and testing. We got to lower the barriers, right? You can't be a multi-billion-dollar global company to be in the game. We got to open this up to academia. We got to open this up to two guys in a garage, right? We got to unleash the entrepreneurial spirit and the creative energy that makes us who we are, right? That somehow we have to open that up, right? So while we need to protect what makes the big guys strong, right, and allows them to pour all of that capital into the innovation machine that is this country, we also need to bring in the entrepreneurial energy and lower the barriers to entry and bring in the new players, the new entrants into this. That is part of equity, and that is part of what always generates new business, new industries, right? Take a look at our history. Take a look at the Facebooks of the world, the Googles of the world, the Amazons of the world. They all started very small, right? We need to generate that kind of an economic engine and ecosystem, right? So how do we do that? We need to lower the barriers and let those types of entrepreneurial and creative minds in the game, right? And you cannot test for interoperability, right? You cannot test and make sure that all of these systems can interact with each other, right? Intercommunicate with each other, and you cannot perform experimentation with co-simulation unless your test infrastructure is interoperable, right? Unless you have middleware solutions so that your simulations can play with each other without having to re-architect your simulation environment. There's no way we're going to get everybody to re-architect their simulation back end. There's just that it's not going to happen. Nobody's going to agree to an entirely new simulation architecture. And so you must have some kind of agreed upon interface, right? And then we need to have, I think we're all coalescing around the concept of scenario-driven testing with some common scenarios. I'm saying that we're going to dictate what the what are the measures and metrics and what's safe enough. What we're saying though is we need a way of doing scenario-based testing, and we need some common scenarios. We need common scenarios to stimulate, everybody's simulation, which means we need some type of a middleware solution that can be, so we can inject these scenarios into a set of simulations, right, to perform co-simulation testing, immerse the simulations into a common environment. I'm going to talk about that in a second. That can only happen if your test environment, your test tools, and your test infrastructure are interoperable, right? That has to happen, and that's what Voices is doing. So that is the challenges with collaboration that we are trying to solve. So we're kind of talked about this. The Voices provides basically a mixed reality platform, right? Mixed reality is a combination of live and virtual that allows this collaborative research and testing to take place, starting with the surface transportation ecosystem for a cooperative driving automation, right? So it's surface driving automation where systems are cooperating with each other. That can be two AVs cooperating with each other or AVs cooperating with infrastructure, right? In a way that protects the intellectual property of all the players. And it's where us public sector folks can work together, of course, with you in the private sector, or you in the public sector, if states and others are out there from the public sector, and of course, academia. I'm going to go through this slide pretty quick so I can get to how it works. Kind of touched on this already. And up here, we have a use case or scenario database. Again, I think that most of the community is coalescing around the notion of scenario-based testing. There's a number of activities around the world now that are working on scenario databases, scenario frameworks. We were going to go and build a scenario framework. We're kind of backing away from that now. We did not want to adopt a particular scenario framework. We did not want to build our own and compete with other folks' scenario framework. Taylor's going to get into the solution that we're adopting. He's also going to get into the community of practice that we have. We have about 100 or so entities that are part of our community of practice. We're very much stakeholder driven, that the stakeholders are essentially driving a lot of our requirements. But what we are doing is building this middleware solution. We're actually adopting it from our friends out of the Department of Defense, U.S. Department of Defense, because they had this problem about 20 years ago and essentially solved it for themselves. So we're taking this middleware solution, and it basically deals with the scenario framework on the back end here, provides a very efficient, tailorable middleware or API that can then adapt to a proprietary simulation engine or environment on this end for an OEM's virtualized environment or that of a supplier. The idea is if you have a virtualized representation of your AV or of your device, be an ITS device, if you're a IOO or an IoT or an ITS manufacturer or vendor, then if you have be it a very high fidelity hardware in the loop, software in the loop, you actually got the sensor models. If you actually have the sensors in the loop, if you have the tactical radios or whatever communication devices that you have, you're pushing out the actual traffic, the actual network traffic. We have very high fidelity representations of whatever it might be, 5G, DSRC, CV to X, that are moving over the networks. You're going to be stimulated by the scenario. It's going to be injected into your virtualized representation of your platform through this interface. It's called TINA, through this API or this middleware solution, through the software interface. It's going to be injected in to stimulate your system. Your system is going to go into your virtualized environment. Your system, let's say this is an AV, it's going to play its role in whatever fidelity of your virtualized system is. Then your system is going to operate in real time. It's going to then be immersed into this mixed reality, or we call it distributed synthetic environment. It's going to play its role. It is going to then see the behavior of all of your sensors are going to be able to sense, let's say, the behavior of all of the other players that are immersed in this distributed synthetic environment. That's going to be pushed back to your sensors in real time. All of this data is going to be moving over a network, a VPN. So there's going to be a software interface through TINA that Taylor's going to be describing to you, and a network interface. It's going to be a very high bandwidth, and it is going to be a closed and very secure network. That network architecture is again being brought to us by our friends from DOD. It is very important to note that all we're getting from DOD is the architecture. DOD has no other role in this, and then it provides a very secure network. It is an unclassified network, but it is very secure. It is architected such that nobody sees your traffic except for you, not us in the government, and nobody else that's participating in the distributed event sees any of your performance traffic but you. Now, what they do see is just your system's behavior as they would in the real world. And they're going to be able to get your network traffic as they would in the real world. If you are generating traffic over DSRC or C-V2X or 5G, then they're going to get that traffic if they're on that network. Right. So that's all they're going to see. All right. Any other performance data, they will not be able to see it. Okay. You're going to be able to get a whole set of tools that are provided that allow you to set up this test, visualize what's going on for your system, visualize what's going on across your network, be able to manage this network, be able to acquire your data, and be able to essentially acquire and capture your data. And so that is basically how this is working. The other players are all doing the same thing. Now, if you just have one of your suppliers here, you could just set a test up between you and your supplier. This is what we mean by a distributed integration test. So you could actually be doing a test. You could actually be doing a test between you and your supplier, so that you could be doing an integration test without ever having your supplier come in and having to integrate physically onto your platform. Or you could be doing a systems integration test with an ecosystem test with an IOO, an infrastructure provider, and another OEM. So that's the whole idea. So we have a number of different tools that are provided, and that allows you to schedule these kinds of tests, and then be able to execute and manage these various kinds of tests. So with that, the value and impact, I think I've done kind of brought up a number of these things already. So for us in the department, we're just seeding this capability. We really don't see how anybody else could, other than the government. We don't see how any one commercial entity or one standards development organization or federally funded research development corporation, FFRDC, could do this on their own. And so as a government, the federal government, we are seeding it. And we're putting together a team to help us develop the requirements. And then it is our intention to turn it over to you, the stakeholder community. We have a series of working groups and a community of practice that Taylor's going to talk about. We see this as a pathway here to prepare for the future. We believe that it is imperative to move us towards that transportation system of the future we talked about. There has to be a way that people and organizations can come together and research together and test together, and they can perform systems engineering together. They can explore different concepts of operation together. That has to happen. You cannot do it in isolation. We cannot wait until you completely coded your software, bent metal, built your stuff, and then thrown it out on a public road to see whether or not it works with the other guy's stuff, right? That is a recipe for disaster, right? You'll lose a bunch of money, right? And we'll all kill a bunch of people, right? And then the public will lose their confidence in all of us, and we will set the country back. We will lose our competitive globalness, and we will have all collectively blown it, okay? And so we are trying to get ahead of this a little bit. And so we are not trying to get in your way. We are not trying to be heavy-handed, but we are trying to give you the tools so that you can work together and with us, right? So this is a way that we can provide you a head start on some of these tools, and it's basically a sandbox, a place where you can come together in a safe environment, safe in that you don't expose your IP, safe in that you don't go and start crashing your stuff together, safe in that we don't kill people in the process of doing our exploratory work, right? And also, this is how we can start to apply this technology in ways that furthers this administration's priorities. right? We can shape this technology to help protect this the climate, right? This technology can drive incredible efficiencies into the system. It is the way that we can do that. How can it not happen? Eco approach and departure, right? How do we get into and out of an intersection efficiently is one of our 3 use cases. Cooperative perception and platooning are our other 2, right? So if we don't apply automation and connectivity to drive efficiency into the system, we've really made a pretty big mistake, right? First of all, selfishly, even if we didn't care about the climate and our future generations, personally, I have an hour and a half commute to get. I live in D.C. I have an hour and a half commute each way, man, 3 hours a day. That's ridiculous. I sure would like to cut that down after COVID. And so I don't like sitting in traffic. So how can we bring some efficiency to that drive? So we should be able to bring automation and connectivity in to bring efficiency into the system. In terms of equity, transportation should be a right, so not a privilege. So how to and accessibility. Everybody should be able to have a seamless, an accessible method of mobility. Everybody. And so this technology should be built into our planning, and it should be made available to all of our citizens in a way that mirrors our values. We should not make the mistakes we've made in the past either. And so that can happen if we take a systems view in our planning. And this technology should be applied out of the gate to make that happen. And so we need to make this technology enabler for all of this. And safety is a given, right? We've all heard 94% of fatalities come from because humans basically screwed up, right? And robots don't get tired. Robots don't get distracted. And robots don't drink, right? But we need to be responsible in the method in which we deploy this technology. And so particularly automation. So it can't just be as safe as a human driver. 35 to 40,000 deaths a year. Are we going to tolerate that in automated vehicles? Of course not. Is that the bar? Is that how low we're going to set the bar for automated vehicles? No. And so we got to do much better, right? And I believe that we can, and I believe that we will, right? But only if we do it together. Right? So this cannot be, and it's easy for me to say as a government guy, this cannot be a race for each of us to win separately, right? If we do that, we will fail as a generation. When I close these kinds of talks and I get fired up as I get going here, I always say that the future is watching us. They are. I mean, it's out there and it's watching. I do believe that we are at an inflection point in history. We got all of this money that's about ready to come in with this infrastructure bill is going to get passed one way or the other, somehow or another, whatever number it is, something's going to get passed. We're going to get an infusion of government capital. How it gets spent, is going to be in large part up to many of us that are in this webinar. Then we have this convergence of multiple technologies that are on the cusp of coming to fruition. When will we have level 4 with significant market penetration? I don't know. You don't know. Does it really matter to the VCs? It probably does. To some of you in commercial firms that are in this race, it probably does. Right? But you know, we don't know exactly when, but we know it will, right? Will level 5 come in our lifetime? Who knows, right? You know, will DSRC survive? Who knows, right? But connectivity is coming. You know, quantum computing, it's going to come. AI, I doubt if there'll be another AI winner, you know, but AI is coming. You know, so all of these different technologies, data science is coming, right? They're going to converge. They're going to mature at different times, right? But they're coming, and they're exponential in nature. So we are approaching an inflection point, a moment in history that's going to significantly transform transportation and mobility. And when that happens, it transforms the way we move people and goods. And that transforms the way humanity sees itself in the universe. And so the future generations will see this moment in history as an inflection point. It will judge us. So are we ready? Are we up for it, right? We will not succeed in their eyes if we approach this all individually as individual races. There will be winners, there will be losers, but if we don't come together and coalesce around some common visions and some common goals and get our act together and move forward together, right? Understanding that we're capitalists, understanding that we will compete, but if we don't do some things together, we will fail as a generation. And when the future generation looks back at us, they're going to wonder what the hell we were thinking about. I think that we can make them proud. So I'm going to turn it over to Taylor, and he's going to give you the nuts and bolts way in which Voices is just one little way in which we can get there. I hope that you join us. So with that, over to you, to my good friend Taylor.
All right, thank you, Rob. We're very excited here to be able to talk to you all about what we've been working on as we develop and build and transfer this technology from government to private sector to help us come together in testing our systems for interoperability as we build these new emerging technologies that we want to integrate into the system to support better transportation activities. So the first thing I want to start with is just dive right into, a high-level architecture that we have and just give you that mental model of what we're building and the different components that our team is working on in putting these pieces together. So, of course, like Rob alluded to, there's a lot of organizations out there with the scenario databases that they use to, hold and use against the modeling and simulation for operating specific scenarios and repeatability and so forth. And so we're not in the intent to build and have a competing scenario database. However, we needed to have one to show how this Voices environment works. And we've been engaging with several different organizations that have really robust scenario databases and how they could use this environment and eventually when this environment becomes transferred to the private sector, that their scenario databases could interface for whatever customers are using their database. So we're kind of working with a community of practice to inform what is needed for the scenario database as we build this shell here. And the other two major components that, leading from the high-level scenario database to the functional scenario database. And then, of course, Rob talked about the data, the results of the database. So when you run an experiment, where does your data go? We're developing a lot of those capabilities. And a lot of the different tools that we're extracting from the federal government, tools of operating these environments using the TINA Execution Manager Console and Data Systems and Data View, as you can see in the middle there. We're leveraging a lot of these tools that have been built by our partners in federal government that we're able to use in helping manage and operate these scenarios. But when you look at the environmental side, the test domain, we're trying to develop those mechanisms for you to be able to bring your products into this environment to test, whether it's a synthetic environment, whether you're synthetic sensors you're bringing in or synthetic actors. We're using the Karma tools developed by Federal Highway as those tools to demonstrate how Voices works, but it's not, you don't need Karma tools to use Voices. But however, since we are developing the Karma tools and demonstrating the use within our 3 use cases within the Voices environment, all of our partners that do use those tools, we would already have those adapters created that they can leverage in using and doing experiments with each other in the academic sense, the industry sense, moving forward. So this high-level architect kind of gives us that big picture of all the different components that we're building. And of course, we can go down into the weeds and get into the details, but this environment is really going to help us, and it's designed so that it's plug and play for different devices and products that industry would like to bring or academia would like to test in this space together and collaboratively. So one of the major components, as you can see on the left, is what we call this community of practice. And so like Rob said, we engaged hundreds of organizations, and today, we're working closely with over 80 participating COP members in this process of defining and informing what goes into this scenario database, what's needed for this functional scenario database, as well as, how do we design this, the results database, and on which tools are needed. So we're transferring the proper tools over to you all from the tools that we have available to us to use. So as I go to the next slide, just to kind of highlight a little bit more on the scenario database overview. Again, we're trying to develop that set of functional and definitive scenarios for each use case. So as we think of cooperative driving automation, it's, for federal highway, our role is looking at what's the role of infrastructure in supporting or enabling this automation. So for us, we look at different use cases in work zones or weather, or, when we look at some of the scenarios we're looking at now, eco approach and departure, or cooperative perception, what are the different scenarios in which we want to operate, and what are all the different partners and technologies that might be participating in that specific scenario, and what's the role that we could be playing. So there's a lot of opportunities in the cooperative driving automation space where we could develop these scenarios, and then we can post them here, and others can take those scenarios and develop and run experiments on them. So this could be that scenario database that we work and build together as a community as we define some of these really tough areas and challenges we see in deploying a lot of these emerging technologies within transportation. The approach we're taking, again, we're working closely with a lot of industry vendors with different products, but we're looking at integrating Carla and Sumo as open source products to also demonstrate the capability, but it's not limiting the capability. You'll be able to use other types of simulation models or vehicle dynamic models in this environment, depending on what your organization uses. So it's very flexible, very robust, and that's the exciting thing about this capability. Defining the labels for test parameters and applicable values, allowing scenario filtering, looking at how we match scenarios to real-world operating environments. These are all the types of questions we're working on with our community of practice. And it's been very, very good discussions we've been having with what is needed when we're trying to put this together, and how do these other scenario databases that exist in the community can interface with this environment and also operate within the Voices world. So looking into the Voices implementation, this diagram kind of gives you that example how this works. So like Robin alluded to earlier, we have a network. The network that we have is what you're going to connect to. So again, what we're learning from the Department of Defense and how they do networking are some of the best practices that we're going to try to apply here, so that when an organization connects to the Voices network, you're able to have a secure connection so that you can connect to any participants in the network to run an experiment. You're going to take your product, you'll write it to a middleware that we'll provide called TINA, and that's basically that universal language communicator that allows your product to talk to someone else's product without having to share your IP. And so there's a lot of opportunities there, I think, for industry to find some safety and comfort in testing it with each other, but also opening the door so where you don't have to go off and do a one-on-one experiment with one vendor. You can just go to this environment, and as long as you're connected to this environment, you will be able to run experiments with any vendor that's connected in the environment upon the agreement of the specific partners. So this opens the door for, again, if you're a sensor vendor, whether you're an ITS vendor, whether you're an OEM or a tier one, whatever product you want to test and see how would my product operate in the system, and how would it interface with these other products that are out there that we want to ensure that there's interoperability, or we want to test with different standards that are emerging. This is a great environment to do that type of testing to ensure that systems of systems interoperability. And when we look at how as we built this, I talked a little bit about the community of practice, and this is how we've organized the community of practice within this organization, the Voices organization. It's very unique. I don't think we've done something like this in at least my tenure within Federal Highway, but working with organizations across the spectrum. I mean, look at the personas on the left, identify how we kind of group different personas together, whether you're ADS developers and manufacturers, your infrastructure owner operators, your researchers, suppliers, and system integrators. And this makes up the over 80 participants within our community practice who are serving on these working groups. Working groups that we have 5 working groups looking at eco approach and departure, platooning, and cooperative perception as our first 3 use cases, as well as tech transfer and systems integration and test. These are the 5 work groups, again, that are partners. And so for those of you on the phone that have dedicated this past year or 8 months working with us in the community practice, we thank you. We've made a lot of progress with your input and guidance and how we design the requirements for this environment based on you all are telling us, what does this environment need to be built for? How do you envision using it? We wanted to design this so that it's ready for your use within your technologies and the things that you're trying to evaluate within your systems as you bring things to market and as you're testing interoperability and systems with partners. So again, shout out to all the COP members that are on the call today. We thank you for your participation. You are a core of this entire design. And so when we talk about these use cases, the 3 that we selected actually were selected by you all from the community practice. We didn't select these ourselves. We asked the community practice to help us prioritize a list of use cases that we all had in common. And these are the 3 that kind of came together. I think eco approach and departure has a huge advantage, I think, of something we could deploy, especially with a lot of the projects that we have going on within the department and outside the department, funded by Department of Energy, that really look at this application as being something that we could do in the arterial side of things. Platooning is a very hot topic these days. Looking at how we're going to apply the platooning aspect, I think this opens the door for, we can use this environment to test different vendors that could be platooning together in that type of a mixed environment to look at, energy efficiencies and so forth, but also look at the role of infrastructure in platooning. If we're approaching a specific bridge, let's say in Federal Highway, we would say this bridge needs repair, or we don't want to allow a specific amount of heavy vehicles to platoon closely together as they traverse the bridge. The ideas that we're looking at within the CARMA program are providing rules on the road where the bridge has a requirement that says, this bridge is limited to two or 3 vehicle platoons, but no more than that. And the spacing is X, Y, Z. So that way, if there's a braking condition, we're not going to put a lot of stress on the bridge deck that maybe is due for repair. So there's a lot of opportunities on how we can work with industry and test those ideas on platooning, but also to help industry enhance platooning so they can deliver platooning together. And it's really, that's the opportunity that platooning working group, I think, has a huge input and value in bringing to the table. And the cooperative perception is a huge emerging idea. We're looking at this a lot from the role of infrastructure side, but as industry, you all have really focused on, how do you share data sensor information that can help us looking at jaywalking conditions or objects that you can't really see but others can see. So how we can start to share that information with one another and deliver on a safe, journey through whatever scenario we want to focus on together. So again, this COP is a huge element of the program, and we definitely want to call out to all the members on the call today. Thank you for your participation, and look forward to the next few working group meetings we have scheduled to keep this ball rolling forward. And so just to kind of show you, here's a sample use case of platooning. This is actually from the J3216 standard published May 2020 from SAE that defined the term CDA, cooperative driving automation, which we focused the development of voices around. And so this kind of gives you those ideas on different classifications of CDA you could operate under. And this environment can help with testing these different types of classes as we start to add these features to our systems. And we want to ensure that we have a good level of systems to systems interoperability. Again, we can test the standards here and test lots of different things related to spectrum and so forth as we're trying to improve our use case of delivering this feature within a specific system. So really awesome opportunity here. And this is just a good idea of showing what we have going for the platooning use case. And then quickly, just kind of briefly going over the schedule to kind of walk you through. We kicked this project off in November of last year, 2021. So we're just about at the 1-year point. We have had a lot of work working closely with the Department of Defense to ensure that we have all the agreements in place to have this technology transfer be a critical element. And we're working great with them. They've been providing a lot of technology to us that we can share with you and give to you through the T2 process and transfer to the private sector. We completed a proof of concept. We call it the garage demo, but we actually applied this in transportation for the first time at the beginning of this year. We demonstrated the ability to have hardware from a traffic vendor influence the virtualized traffic intersection that was interfacing with simulated vehicles. So we were able to test the capability of converting and creating all these adapters for all these different standards, NTCIP and all these different types of methodologies we have of sharing data and converting that into TINA and having these systems still be able to effectively communicate with each other through the TINA middleware. And that really injected us moving forward. We launched the COP organization, the COP community practice in March of last year. And since then, I believe we've held over 18 meetings with the working groups in developing these requirements for this environment, again, for you all. And so, again, we didn't want to build this environment with our own ideas. We want to build this environment that suits the needs of the partners and the people that have a vision or have a desire to use this technology to enhance their products and enhance their interoperability and systems of systems performance. Moving forward, we're going to be testing some different capabilities, moving from local testing to distributed testing across the country. And then eventually we'll be selecting specific nodes, which would be points around the country where we will bring online so we can demonstrate that you can run a test from Los Angeles to DC at the same time without many impact due to latency. Using the TINA software, you won't have to bring those organizations together. You can do it through the distributed network testing platform, which is Voices. So there's a lot of great, I think, opportunities we have. This year is going to be a big year as we start to complete all the requirements with our community practice members, as we start to prepare for the demonstrations of these use cases, and as we start to prepare for the technology transfer and hand this technology out to you all. We are not going to be owners of this technology. We're not going to be managers of the data. One thing, I guess, to note, in the Voices environment, the user that wants to run a test defines where the data goes. So the government's not going to have any access to data or any access to this network for any reason. It's just going to be a privately run network, and we will be just a user. And if we want to run an experiment with any of you, we would love to. We would love to run experiments with you all and see how we can test these cooperative driving automation scenarios and how to enhance the standards that are needed moving forward, working with our SDO partners. So this is definitely going to be an asset to us to engage with you all in the development of systems testing at the early level. So with that, I'm going to go ahead and just go put one more slide up here on the upcoming webinars that we have today. Again, was just our overview, but we're going to be launching 4 more webinars looking at the use case development, the TINA Karma integration, how we did it and how it works as an example use case. So you can kind of envision how this would look for your products and how you would add your solutions to this environment so that you can start to test with other people and test with your products. We're also going to be having a webinar on the tech transfer. And then the final one would be looking at the final use case testing and reporting towards the end of the program. So Voices is looking at completing by the end of this year, not this year, next year, 2022. And we hope to deliver this asset to you all and continue working with you all in advancing cooperative driving automation in the country. So with that, I will pass it over to Nicole, and thank you all for taking the time to listen to me go through these slides.
Thanks, Taylor. So the floor is now open for questions, so feel free to use the chat pod to submit those, and we'll address as many as we can get through for the whole group. There are a couple comments already being discussed in the chat pod, which is great, but just to bring them to the whole group, the first couple questions are about the scenarios. So are the high-level scenarios shared, and how can we view those? And also, will Voices support abstract scenarios, logical scenarios, and concrete scenarios?
It looks
Nicole,
like,
this is Taylor. Sorry.
Go ahead, Taylor. It looks like Jeremiah jumped in and started to help answering some of those questions, and I would offer too any of our technical team that's online, please feel free to jump in and help Taylor and I, as Bill to provide any technical support here. But Taylor, I'll defer to you. And it looks like Jeremiah has already jumped in a bit there, but I'll defer to you on this one, Taylor.
Great. Sorry. So as you were talking, Nicole, my earpiece fell out. So I was taking it up and putting it back in my ear. Can you repeat the question real quick?
Sure. So we have kind of a couple steps of the question. Are the high-level scenarios shared, and how can those be viewed? And also, will Voices support abstract scenarios, logical scenarios, and concrete scenarios?
Okay, so yes, we're going to be sharing these high-level scenarios soon. We have a Confluence site set up, but as we are developing this material with our community of practice, we're working on it with them, and then we're going to be sharing them as those documents are getting completed. So we'll keep you informed as to those where you can go out and get some of the information regarding the scenarios you're talking about, the high-level scenarios. But we will share those, of course. But right now, we're just in the middle of working with our community of practice members and rounding some of those out, and then we will make those available, of course. As for the abstract and logical and concrete scenarios, this environment is built to be an LVC. So it's built to help and support the live, virtual, and constructed type testing. So it will have the capability to do so.
Next question is, some of the tools, for example, Carla, do not inherently support V2X. Is there a plan to extend their capability or introduce other V2X supporting tools?
That's a really good question. I'm glad you brought that up. So within the Karma program at Federal Highway, we have an effort called Everything in the Loop. We refer to it as XIL. And we're in the process of developing that technology for interfacing a Carla with Sumo with NS3 to provide that layer of connectivity testing using NS3. So we are using a platform, I think that's developed by the Eclipse Foundation called Mosaic to kind of assist with that. And we're working with a lot of those developers and academic partners across the country and internationally that are part of the Mosaic community to create those interfaces between Carla and V2X. So that's underway, and we've actually demonstrated that already within our team, and we'll be having some releases come out within the Karma program to provide some of that functionality. Again, that's under XIL program that we have, but we will be able to add this to the Voices environment as all the code that we're developing for that V2X and Carla is going to be open source. It will also be added back to the community to then bring that forward within everybody.
And if I could just pile on in a more generic sense, that one of the principal requirements and purposes of Voices is to perform interoperability testing. And so as different protocols come into play, then that'll be some of the leading requirements that we'll be prioritizing for incorporation into the program. Over. And one of the principal purposes of the community is to help us identify and prioritize requirements. Thank you.
Okay, next question. What is USDOT and FHWA's vision for implementation? Is this a voluntary system?
That's a great question. Our plan with this is during the T2 process, we're going to be working on helping develop and strategize business models so that this product can be self-sustaining with the partners and partnership and people that are using the product. So it won't be it's not going to be a required product. This is not a regulatory environment tool. This is a research tool to help with people and researchers and organizations test collaboratively with each other on software and tools that they're developing for their own organizations. So it's a voluntary tool in that aspect that you don't have to use it. It will be available to everyone in the community. But at least this capability that we're providing does not exist today. And so we're trying to provide this technology to you all. So if in the need of having to do this live and virtual constructed testing for transportation, is a demand in your organization, this capability will be available for your organization to participate in.
So yes, completely voluntary. So we are thinking about, you know, as we mature, we can't develop some Voices swag. And if you want a Voices hat, then you'll have to be part of the Voices, you know, community of practice and a Voices user to be able to get a Voices hat. But that'll be about it. But that was a joke. Sorry.
So our next question is, what is the common domain model that we will be using?
Can you just make a little bit more clarity, Richard, on your reference to common domain model? We have a few different, I think, terminologies on what that can mean. I just want to get some more from you. So let's move to the next question, and after that, we'll come back to Richard's question on common domain model.
Great. So I see the next question is, what is the relationship and connection between Voices and Karma?
Hey, Guyan, thanks for the question. So there's a great relationship between Voices and Karma. We're using, as Karma is an open source set of tools that we've developed to research and understand CDA. As we in Federal Highway, our goal again is to look at what is the role of infrastructure in supporting or enabling CDA, this automation space. And so the relationship between Karma and Voices, that we're using the Karma open source tools as a way to demonstrate how Voices works as we build it. So because we couldn't just pick a vendor or those in the private sector say, hey, we want to use your product. We decided that, we wanted to use this open source tool set that we have control over, so that again, we can design it, we can test with it, we can show you all how it works, and we can help industry understand and see. It takes a lot of time, so you have to see this software, see how this technology is going to enable you to do really fascinating things. So that's where the Karma and the Voices programs kind of support one another, because as Karma is added to Voices, it becomes an asset to our program, because now we can use the Voices network once it's deployed to be able to interface with other vendors and products and do more fascinating CDA research as we, again, are focused on looking at what is the role of infrastructure.
Yeah, and if I could pile on there a little bit, Nicole, so I think this is very symbiotic in that, again, we're trying to lower the barriers to entry for folks to be able to perform collaborative research and testing. So let's say that you're an academic institution and you want to get into this field of, let's call it CDA research. I'm just building, let's say, one part of the autonomy stack. And I don't want to go out there and I don't have the resources to buy a $300,000 autonomy vehicle, or take some kind of a vehicle and rebuild it with an autonomy stack. So I can bring in Karma, let's say, and then all of a sudden, for very low cost, with an open architecture, I can basically just plug in my piece of the autonomy stack and start experimenting with it rather readily and rather cost efficiently. And then if I can bring in a Voices node, if I can become a Voices node, like now I can start to perform very collaborative research, CDA research with other researchers, including some of the much larger or some of the other smaller research institutions or OEMs. If I wanted to get involved in some kind of a joint grant program or collaborative research initiative, or connect with some kind of a government research lab, it makes me eligible to participate in some kind of a joint grant proposal, and so it is offering those kinds of opportunities to institutions that otherwise would have had a difficult time participating in this research area. And so that's where we believe the marriage, this is one area where we believe the marriage between Karma and voices can yield significant opportunities for a growing community of research and development. Thanks.
Great, thank you. Our next question is kind of a two-parter. How can people get access, and when can we get access to the platform? And also, can non-US participants join the Voices community and contribute to development?
As for access, we are going to be releasing this code through, of course, GitHub and all of our open source actions. We have Confluence for documentation. We have, again, GitHub for source code. So as we're developing the Voices network and Voices environment, those tools that we develop that are open source that we're going to be providing, we will be putting them in those locations. We have those already set up, and we are building in those environments. They are turned off right now publicly as we are working with our COP members to continually to build them, and with our other partners within the DOT to ensure that we're building these towards our requirements and everything works. But once we get to that release date, probably sometime later this summer, we'll be starting to turn on and make all those documents available. But again, we're still working closely with our COP members, and everything is still in development. So as we start to finalize those things, we'll be letting all that information out.
Great. Our next question is, how many scenarios do you envision will be shared with the community?
We're developing within, for the demonstration purpose, 3 scenarios that we've selected within our COP, but the COP is talking about lots of different other scenarios within their working groups, because there's just lots of different things to do and lots of questions that everyone has on how these systems related technology questions could be using voices to help them address the safety, operations, efficiency, and so forth that in the infrastructure and the transportation system. So there's just so many different types of scenarios that we could develop, and that's why, again, we're kind of developing this initial scenario database to host some of those ideas so that we can help industry get going. But there's a lot of different scenario databases out there, so we're not trying to compete with anybody, and that's why we're also trying to make sure that other databases could interface with voices by creating that API structure. But for what we're doing with our community of practice, we've only kind of focused on 3.
Great. And that's kind of a follow-up to that. What scenario format will be used to publish scenarios?
So we're working on scenario format. Again, we're trying to use like best practices. So again, Open Scenario, Open Drive, some of those standards that are available today that are being developed by a lot of you all are key leads in those standards. And so we're leveraging what's available within the open source. Again, we're not trying to write something special or unique, but based on the requirements that we're getting within our COP members in defining these demonstrations, well, there are new things we're going to have to develop, and that's what we're going to be contributing to the community within this space.
And if I could pile there as well, Taylor and Nicole, as I mentioned earlier, our original plan was to develop our own framework and develop our own database. And we just found that there was so much other good work going on around the globe that it just didn't make sense to create our own. And so it would be great if we could all harmonize around some common approach and common framework. And not sure if that's actually going to happen. It seemed like there were some leading candidates out there. So we elected to try to find an elegant solution that could accommodate as many of those leading candidates as possible, so that voices could easily be able to incorporate as many as possible, as seamlessly as possible. So we're working with the COP partners to try to find the most elegant solution that we can, or devise the most elegant solution that we can. Though we are rather committed to, again, the scenario-based approach. And then we're also working with the various entities that have developed safety validation and measures and metrics, and those types of analytical approaches to measuring safety validation or assuring safety. And there's a number of them out there. I'm sure that most in our audience are familiar with those. So we elected to not get into that business either, but rather start to pay close attention to those to ensure that as our tools are collecting data, as we're starting to harvest the data off of the synthetic environment coming through our network and then back in through our data aggregation tools and data collection tools, that we're able to do so in a way that they would feed those various analytical methods, those various analytical tools. And so we're kind of trying to look at it from both the front end to be as open and as flexible as possible, and at the back end to be as open and as flexible as possible, if that makes sense. So that as the scenarios are being basically injected in, we can take just about any kind of scenario and scenario framework, and on the back end that we can feed just about any type of safety validation analytical approach or analytical tool. Over.
Fantastic. Our next question is, it would be helpful to provide a specific example of where voices would accelerate experimenting, deployment, and other goals.
So,
did you want to?
I mean, there's lots of examples. Rob, do you want to take this one?
Why don't we both? I'll take a shot first. Voices, from my perspective, isn't as much about if I have one AV or one shuttle or one piece of infrastructure or one software tool that would go into a some kind of a traffic management system. That's really not where voices is going to yield the greatest value proposition. And until I need to demonstrate that my system needs to actually interoperate with other systems, which eventually I think that almost every system will. And not just interoperate, but interact. So I believe that, as I mentioned in something like my second slide, we are entering a world, a transportation ecosystem, where just about every system is going to be immersed within a connected and intelligent transportation ecosystem. And so one way or the other, your system is going to be eventually connected. If it's got a microprocessor in it, everything's got a microprocessor in it, eventually has a communication interface. And then that communication interface is going to be connected to a network. And you do that so you can connect to something outside of your system. That's just the way digital systems go. Name one digital system that isn't connected to another digital system. That's just the evolution. Everything's got a microprocessor in it. And so vehicles are going to be the same way. Infrastructure is going to be the same way. And so that's going to happen. And when that happens, you will eventually become somehow, you're going to become dependent on that network and whatever data is flowing through that network. And that happens very quickly once you hit that inflection point. And so you're going to have to be able to test that connection and that data and that ConOps and that interoperability and those vulnerabilities. And so, and it'll sneak up on you. And so we are trying to be prepared for that. If you are going to have to communicate with the infrastructure, if you're going to have to communicate with another vehicle, if you're going to have to communicate even homogeneously with your own vehicles in a fleet, then, or, if you're going to have to communicate with the cloud to be able to get back to the fleet management system, it's like OnStar or something like that, back with your own fleet system for predictive maintenance, things of that nature, then that is going to have to be tested. And that is also going to introduce vulnerabilities, and it's going to introduce an attack vector and an attack surface for cyber. And so all of that is going to have to be tested, and it's going to have to be tested before you get out in the real world. And so those are all use cases. And those are all use cases that you better be able to test before you get out in the wild. And if in any way, it's going to have to be tested with systems that you don't own, that you don't control, then you're going to have to be able to somehow collaborate with those other owners and find ways to be able to experiment, explore, research, and test with them in a high fidelity environment, off the live network, right? And in some kind of a test environment. And so there are so many use cases that it becomes, if you describe a use case, we could probably describe 100 use cases. And so it's countless. Tell me what system you're responsible for, and I'll give you 50 use cases in the next 10 minutes. Taylor?
Yeah, I mean, the first use case that comes to mind that's a difficult one, that's an emerging technology, is cooperative perception. The ideas around, infrastructure, detecting objects and sharing object information with CDA-enabled vehicles approaching an intersection. There's a lot of different types of experiments that would need to happen there, because there's lots of different products and sensor fusion algorithms and detection algorithms and different technologies involved in the cooperative perception use case. And so testing your system, if your system is going to require or need or want to use that information feed coming from the infrastructure, this environment could be used to help test that. Other ideas are, injecting live data from traffic information systems into this environment so you can test against live data, like a corridor or a highway, where you have data with traffic signal operations, a corridor operating specific traffic control signal timing plans, and it's producing specific information to support eco approach and departure or other types of algorithms. This environment could be used to bring in that live data from a real operating environment, and then you inject your product and interface with other products to evaluate the performance of an activity that you're trying to investigate, solve, design, build, test.
Great. So I'm just keeping an eye on the time. I think we have time for about one or two more questions. So our first question, what is the target SAE autonomy level in Voices?
Voices is not related to an SAE autonomy level. It's related to whatever product you want to bring in, or a person wants to bring in to evaluate in the terms of cooperative driving automation for at least the environment we're building it for with you all in the community of practice. So as long as it's focused on machine-to-machine communications, it doesn't have to be geared towards a specific autonomy level. It could be a traffic controller system that you want to bring in, or a sensor that you want to bring in to test. It could be lots of different products that could be used. So it's not tied to a specific SAE level.
But I would say that it could handle just about any. I mean, not to overstate it, but it can handle 2, 3, 4. If you wanted to play with 5, and it can handle any of them. It's really doesn't, and it's another way of, and I guess it's another way of answering the same way that Taylor said. It doesn't matter.
Great. So our final question for today will be, is Voices a communication standard?
No, Voices is not a communication standard. Voices is just the environment that we're developing to enable this testing capability, but it's not a communication standard. It relies on specific middleware that helps provide that connective tissue between industry products, but it's not considered, Voice is not considered a standard.
Voices, we do think we do have SDOs involved as part of the communication, as part of the community of practice, and we believe that Voices could be a mechanism that would facilitate the development of standards, and Voices could be a tool to validate standards and to validate compliance to standards. But Voices in and of itself is not a communication standard. Is that fair to say, Taylor?
Yes. Yep. Thank you, Rob.
So when I say that it could be used to validate compliance to standard, please do not interpret that as any form of a regulatory tool. It is not meant for that.
Great. I think we will wrap up there for today. Thank you to NOCO for hosting, and to our speakers, and for everybody attending, and for all of your really great questions today. This is a really great conversation. I will hand it back over to Kevin for some closing reminders.
Thanks, Nicole, and thank you to all of our attendees for attending today's webinar. And thanks to Nicole and Taylor and Rob for their presentation. Like I mentioned in the beginning, a recorded session of this webinar will be available, along with the presentation slides, will be available on the NOCO website. On behalf of the National Operations Center of Excellence and our presenters, thank you for joining us today, and we hope you have a good rest of your day.
Thank you, everybody.
Recording has stopped.